This is a material that is revolutionizing various industries. From construction and transportation to aerospace and renewable energy, their potential is truly remarkable. FRP, which stands for fiber-reinforced polymer, also known as fiber-reinforced plastic, is a type of composite material made by combining strong fibers with a polymer resin. The fibers, which provide the main strength and stiffness to the material, are typically made of glass, carbon, or aramid. The resin, which binds the fibers together and protects them from wear and tear, is usually a thermosetting plastic such as epoxy, polyester, or vinyl ester. FRP pipes are a type of composite pipe made from a polymer resin reinforced with glass fibers. The fibers provide strength and stiffness to the pipe, while the resin protects the fibers from corrosion and other environmental factors. FRP pipes are produced by the extrusion method. This is a continuous process in which the fibers are pulled through a die and coated with polymer as they go. The Pultrusion process allows for continuous processing of high volume lengths of FRP profiles. The possibilities for simple to complex shapes is almost endless. The process starts with creels of fiberglass unidirectional roving. These reinforcements provide strength along the longitudinal length of the finished pultrusion. As we move forward in the manufacturing process, the next reinforcement in line is the continuous filament mat or CFM. CFM provided strength across the width or transverse direction of the finished pultrusion profile. Both sets of fiberglass reinforcements are sent through a preformed guidance card to begin the profile forming process. As the fiberglass gets closer to the resin bath, most profiles are introduced to a synthetic surfacing veil. The veil is used to provide the finished profile with a high-quality surface finish as well as provide an additional layer of corrosion and weathering protection to the pultrusion. Now that all of fiberglass and veils are packaged together, they are introduced to either polyester or vinyl ester resin. The resin bath is designed to completely saturate the fiberglass package. The resin consists of base polyester or vinyl ester, fillers, pigments, mold release, and catalyst. As the pultrusions continue to pull forward, the resin and fiberglass is then formed into the shape through a set of custom machined CNC cards. These cards are carefully machined to the profile geometry, so the package can easily enter the pultrusion die. At this point, the resin and fiberglass are then pulled into a heated pultrusion die. The resin and catalyst are heated to the specified temperature. Once we reach the specified temperature, exothermic reaction happens, turning the part from a liquid into a thermoset formed hard FRP profile. The fully cured profile exiting the pultrusion die is advanced down the pultrusion line by a pair of dual reciprocating hydraulic puller clamping stations. These stations work in tandem hand over hand to create a continuous pulling action. The word pultrusion comes from this process of pulling and extrusion, thus the word pultrusion. The last step in the manufacturing process is cutting. The pultrusion machine will keep an automatic count in lineal inches or lineal millimeters of the output after each cut. As the encoder records the output produced between cuts, once it records the set cut length, it will activate the saw to generate a new cut of the pultrusion being manufactured. Manufacturing GRP tanks through hot-pressed SMC compression molding. Design flexibility. FRPs can be molded into complex shapes, making them suitable for a wide range of applications. High strength to weight ratio. FRPs can be much lighter than metals while still having the same or even greater strength. This makes them ideal for applications where weight is a critical factor. The compression molding process for FRP, fiber reinforced plastic, production is a widely used technique for creating high strength, lightweight parts with consistent quality. Material prepping. The FRP material in the form of sheet molding compound is cut to the desired size and placed into the mold cavity. These premixed compounds contain chopped fibers embedded in a resin matrix. Mold setup. The mold cavities are heated to a specific temperature depending on the materials used. This preheats the mold and accelerates the curing process. Molding. Compression. The mold is closed with significant pressure applied by a hydraulic press. This pressure forces the FRP material to flow into all the mold cavities, ensuring even distribution and eliminating air voids. Holding. Pressure and heat are maintained for a specific time, allowing the resin to cure and solidify the FRP part. The curing time depends on the material and part thickness. Post-processing. Mold release. Once curing is complete, the mold is cooled down and opened. The finished FRP part is then ejected. Trimming and finishing. Any flash, excess material, around the part edges is trimmed off, and additional finishing or machining may be performed depending on the part's requirements. Fiber-reinforced polymers are becoming increasingly popular in the construction industry. FRP bars used to reinforce concrete beams, repair of cracks and damage. FRPs can be applied to patch cracks and repair damaged concrete, wood, or steel components. This can extend the lifespan of structures and improve their safety. Concrete reinforcement. FRPs can be used as bars or sheets to reinforce concrete beams, columns, and slabs. This is particularly useful for retrofitting aging infrastructure or structures in corrosive environments. Why is fiberglass used in construction? Fiberglass is used in construction for a number of reasons, including high strength. Fiberglass has a high tensile strength, which is 10 times that of steel. This allows fiberglass reinforced materials to have excellent load-bearing capacity, impact resistance, and bending resistance. Fire resistance. Fiberglass has high heat resistance, up to 500 degrees Celsius. This allows fiberglass reinforced materials to have excellent fire resistance and flame retardancy. Moisture and water resistance. Fiberglass has good moisture and water resistance. This allows fiberglass reinforced materials to protect structures from the elements and prolong their lifespan. In addition to these advantages, fiberglass also has other advantages such as lightweight. Fiberglass is lighter than steel, which can help reduce the weight of a structure and save construction costs. Easy to install. Fiberglass can be fabricated into a variety of shapes, making it easy to install and assemble. Environmentally friendly. Fiberglass is recyclable and reusable, making it environmentally friendly. GRP pipe are commonly used in the world as the main pipe for water supply and drainage pipe network. GRP pipe is a new type of composite material pipe. GRP pipe continuous winding production line are mainly made up of control system, power system, heating system, curing system, cutting system, detection systems, socket joint assembly system, 7 subsystems. All the system automatically in the control of the computer. GRP pipe continuous winding production line in the current market is the most efficient. For example, the nominal bore is 1 meter. The daily output of single line can reach more than 400 meters. It has a high degree of automation. It has the characteristics of digitization and intelligence. It has the function of early warning alarm and automatic correction. Continuous winding process on a continuous output die. Resin. Continuous fiberglass. Chopped fiberglass and quartz sand are laid out in scientific proportions. In the way of 3D printing, the continuous winding GRP pipe is made. It is completely different from traditional methods. It is an industrial revolution. The 3D wall structure and unique production technology which improves the mechanical property. The connected fittings are full rubber sealing ring sleeves. The exterior is made of high-strength fiberglass. The inside is EP ring. There are many lip teeth. Each tip tooth is a guarantee for closed water. It is not easy to fall off. Joint is stable. It has strong foundation subsidence resistance and earthquake resistance. The pipeline can be deflected at a small angle. It can meet various working conditions. FRP fiberglass skylights are a popular choice for residential and commercial buildings due to their durability, affordability, and ease of installation. They are made from a composite material of fiberglass and resin, which gives them their strength and weather resistance. Benefits of FRP fiberglass skylights. Durability. FRP fiberglass skylights are very durable and can withstand harsh weather conditions. Affordability. They are more affordable than other types of skylights, such as glass or polycarbonate. Ease of installation. They are relatively easy to install and can be done by a DIY. Lightweight. They are lightweight, which makes them easy to handle and install. Versatility. They are available in a variety of shapes, sizes, and colors. Energy efficiency. They can help to improve the energy efficiency of a building by providing natural light.